Welcome to everyone with the Team SafeHarvest here to represent a solution for Smart India Hackathon on the problem statement of affordable on-site testing of aflatoxin contamination in groundnuts and maize on the theme of agriculture and rural development food safety. As we did a lot of research and found that in India, aflatoxin contamination in maize is largely growing. Aflatoxin is a toxic substance produced by fungus. It is invisible to the naked eyes, but it causes a serious health problems like liver damage and cancer. For farmers, it leads to the huge financial losses because contaminated crops are often rejected in markets and exports. Currently, testing is done only in a specialized labs. This process is slow, costly, and not available at village level. This creates a big gap. Farmers needs a simple, affordable, and a portable solution to test crop instantly before selling. That is the challenge we are solving with our project. Aflatoxin contamination is a hidden but a serious threat in crops like groundnuts and maize. It is caused by a type of fungus that grows during the storage or in damp conditions. On the left side of this slide, you see the problem. Aflatoxin leads to a severe health risks such as liver damage, causes exports and market rejections of produce, and testing in laboratories is often costly and slow. This issue results in the loss of income and livelihoods of farmers. On the right side, you can see how it spreads. The fungus contaminates suspicious foods like grains and nuts. These then become a part of animal feed. Then, through milk, meat, and eggs, the toxin enters human diets, causing food poisoning and other health issues. Because this contamination is invisible to the eye and different to the defect in the field, there is a strong need for quick and affordable on site testing. That is why we purpose a handheld aflatoxin scanner. Then we can help farmers and traders identify contamination early and prevent its spread. This slide explains the technical approach of our handheld aflatoxin scanner. On the left side, you see the system architecture. First, the farmer places a small grain sample into the device. Next, the UV or LED light source shine on the grains. If the grains are contaminated with aflatoxin, they show a specific fluorescence glow under this light. The sensor module detects the fluorescence and sends the data to the processing unit, which is microcontroller or processor. The processor then analyzes the signal and determines whether the grains are safe or unsafe. The result is immediately shown on the output display using a simple indicators, green for safe and red for unsafe. On the right side, you can see the prototype of the handheld device and an example image where contaminated grains appear highlighted under UV light. This approach makes testing simple, quick, and affordable so farmers can check their crops on site without sending them to distant labs. This slide focuses on the feasibility and viability of our handheld scanner. While the device is designed to be simple, we identify some practical challenges and prepare solution for each. First, external light, dust, or dirt could disturb readings, leading to the unstable results. We solve this by using a light tight chamber and a standard sample cup to ensure consistent testing. Second, farmers may misuse the device, which could give unreliable readings. To address this, we plan a simple, user friendly interface and provide a basic awareness training. Third, because different grains varieties fluorescent differently, this is the risk of inconsistent detection. We handle this by calibrating the device for major Indian grain varieties. Since the device is portable and battery based, power drain during field use could be an issue. Our solution is to use a rechargeable long life battery. By tackling these challenges early, we ensure that the scanner is practical, reliable, and truly useful for farmers in real world conditions. About the impacts uh, on farmers, reduced crop rejections, higher income due to better prices. For consumers, safer food, low health risks from aflatoxin contamination. And for government and agencies, easier food safety checks and more efficient operations. The graph shows a crop rejection rates drop significantly from 60% to 10%. Farmers income increases sharply from 40,000 to 1,40,000. Benefits about that: social builds a trust on social level builds a trust between farmers and buyers with a safer food. For economic, increased farmer income reduces testing cost, and for environmental, reduce of food wastage promotes sustainable farming. A pie chart shows that the stakeholders who benefit: farmers about 29%, consumers nearly 28%, and for government 23%, and for traders 20%. Conclusion: to conclude that the safe harvest is not just a device, it's a complete solution for farmers and consumers. It is simple, affordable, and portable. It puts food safety directly in the hands of farmers, protects consumer health, and strengthens India's agriculture supply chain. With the safe harvest, farmers will no longer fear invisible contamination, and consumers can trust the food they eat. These are the research and references we use in our PPT, and thank you for listening.